Good morning friends, welcome to JCE Connect. Today's subject is Additive Manufacturing 15 ME 82 C Division Module 5.3. Myself Dr. Anand K. Usmani, Jain College of Engineering, Belagavi. Let us see the overview, introduction, components, classification, advantage, disadvantage, applications. Introduction to CNC machine tools. CNC refers to computers that is joined to the NC machine. CNC means computer numerical control, NC means numerical control. CNC refers to a computer that is joined to NC machine to make the machine versatile and is defined as a method for automating control of machine tools through the use of software embedded in microcomputer attached to the tool. It is commonly used in manufacturing for machining metal and plastic parts. Mills, lathes, routers, grinders and lasers are common machine tools whose operation can be automated with CNC. The program is read from a storage medium such as punched tape and retrieved to the memory of CNC computer. Components of CNC machine tool system. CNC system basically consists of following, that is, we have central processing unit CPU, servo control unit, operate control panel, machine control panel, programmable logic controller, other peripheral devices. First we will see central processing unit, CPU. CPU is the heart of CNC system. It accepts the information stored in the memory as a part program. The data is decoded and transformed into specific position, control and velocity signals. It also oversees the movement of control axis or spindle, and whenever this does not match with the programmed values, a corrective actions as taken. Servo control unit, the position and velocity control signal generated by CPU for the axis movement from input to the servo control unit. The unit generates suitable signals that are converted by the servo drive, which are interfaced with the axis and spindle motors. Next we have operate control panel. The operative control panel provides user interface to facilitate a two-way communication between the user, CNC system and machine tool. This consists of two parts, video display unit and keyboard. Machine control panel. It is a direct interface between operator and NC numerical control system, enabling the operation of machine through the CNC system during program execution. The CNC controls the axis, the motion, spindle function or a tool function on a machine tool depending upon the part program stored in the memory. We have program logic controller. A PLC matches the NC to the machine they developed to be reprogrammed without hardware changes when requirements were altered, thus are reusable. PLCs are now available with increased function, more memory and large input or output capabilities. Other peripheral devices, this include sensor interface, provision for communication equipment, programming unit, printer, tape reader, interface, etc. We will see the classification of CNC machine tool. it is based on the motion type. Point-to-point system. Cutter and the workpiece will be placed at the certain fixed relative position and cutter will be performing its operation. Continuous path system basically involves motion of workpiece with respect to cutter while operation is in process. Based on the control loops. Open loop system, programmed instructions are fed into the controller through an input device. These instructions are converted to electrical pulse signal by controller and sent to the servo amplifier to energize the servo motor. There is no feedback system to check whether the program position and velocity has been achieved. Here we have command signal motors, machine slides, and in closed loop system, the closed loop system has a feedback subsystem to monitor the actual output and correct the feedback system. Could be either analog or digital. Closed loop systems are very powerful and accurate because they are capable of monitoring operating condition through feedback subsystem and automatically compensating for various variation. Here we can see the motors, machine slides. Feedback is given by the machine slides to the comparator, and from comparator to the motors we have that is positioning signal. We can call it as a displacement measurement unit. Based on the number of axes, we have 2 and 3 axis CNC machines. CNC lathes will be coming under 2 axis machine. There will be 2 axes along which motion take place. The saddle will be moving longitudinally on a bed, along a bed. There will be 2 axes along which the motion take place. The saddle will be moving longitudinally on the bed Z axis and cross slide moves transversely on the saddle along X axis. In a 3 axis machine, there will be one more axis perpendicular to the above 2 axes. Complex surface can be machined. We will see about the 2 axis milling machine and 3 axis milling machine we are going to have. In that, milling is an important technique used in CNC precision machining, having application for medical, aerospace, optical as a mechanical part. Milling uses rotary cutters to remove material from a workpiece by feeding the workpiece at an angle to the axis of the tool. The axis that a milling machine has determines the type of work and locations in which it can be done on the workpiece. Here we look at some 3 axis. We'll see 3 axis milling evolved from the practice of rotary filling and is a milling process that operated on a 2 axis, the X and Y axis. In 3 axis machining, the workpiece remains still while cutting tool moves along 3 axis to mill the part. 3 axis machining still one of the most widely used technique to create mechanical parts and can be used for automatic interactive operation. Milling slots, drilling holes and cutting sharp edges. Because 3 axis machining only operates on the 3 axis, it is relatively simple and allows material to be removed in the 3 axis. While it is more basic machining process, 3 axis machining may be ideal for your machining project depending on the size of your production run, the workpiece requirement, accuracy and finish constraint, materials used for your holding capabilities. We have the 4 axis CNC machine. 4 and 5 axis CNC machines provide multi-axis machining capabilities beyond the standard 3 axis CNC tool path movements. 5-axis milling center includes the 3x, y, z axis, the a-axis, which is the rotary tilting of the spindle, and b-axis, which can be rotary index. Here we have seen 3-axis, 4-axis, and 5-axis machine. Let us see the 4-axis milling involves the 4-axis, that is the company of Crystal Company. They have shown the 4-axis milling involves the same process involved in 3-axis machining, where a cutting tool is used to remove material from a piece to create the desired shape and profile. However, in the case of 4-axis machining, milling is performed on an additional axis. 4-axis CNC machine operates on X, Y, and Z axis like a 3-axis machine, but it also includes rotational around the X axis. This point you should be noted. It also includes rotation around the X axis, which is called the A axis. The fourth axis that added to our machining process. In most cases, the workpiece will be rotated to allow for cutting to occur around B axis. 4-axis milling is useful when holes and cutouts need to be made inside in the side of the piece or around a cylinder. This can provide quick and efficient work based of computer numerical inputs from the precise result. If you see the 5-axis machine, 5-axis machining involves all the 4-axis machining with an additional rotation axis. 5-axis milling machines are the best CNC milling machines available today, capable of creating precise and intricate parts for artificial bones, aerospace products, titanium piece, oil and gas machine parts, car molds, medical, architectural, and military products. The 5-axis milling machine is around the B axis, which rotates around the Y axis in the XYZ plane. The multidimensional rotation and tool movement allows from B axis unparalleled precision, finish, and speed in the production of a piece. 5-axis machining can create very complex parts, which is why it is so important for high-level uses such as aerospace application. 5-axis machining is also becoming more popular because it offers the option for single-step machining, allows better access to part geometry, and improves the tool life and efficiency of the process by tilting the tool life and efficiency of the process by tilting the table for the ideal cutting position. And here we have that is about a 5-axis. Next we will see about the advantage of CNC machine. The setup time for CNC machine can be reduced. Time required to manufacture a component is very less when compared to other conventional machine. High degree of accuracy can be obtained. Longer tool life. Tool can be used at optimum speed. Flexibility in changes of the component design. Elimination of special jigs and fixtures. Time spent on inspection is greatly reduced. Minimum waste of material. Accurate costing and scheduling. Disadvantage: higher investment cost because of its more sophisticated and complex technology. Higher maintenance cost, require higher skilled persons. And application, that is in metal cutting machine tools, welding machines, inspection machines, automatic drifting, assembly machines, tube bending, laser beam process, etc. These are the applications. Thank you very much for watching patiently.